Right? Thank you. All right. What are the laws of motion? So we're going to talk today about the three major laws of motion. Isaac Newton also talked about like gravity and stuff, but we're going to focus on his first three laws. Yes. Woo! Woo! That was close. That law of gravity almost got me there. Newton's first law. You ready to have your life changed?
Oh, yeah.
An unbreakable law of the universe. That's kind of big. First law says, you don't have to excuse Isaac Newton because he's kind of old and he wrote in the weird English that nobody really understands, thou, thee. So we're going to look at what he said, then we're going to kind of dissect it. He said, in the absence of a net force, an object at rest will stay at rest, an object in motion will stay in motion infinitely along the same straight line. What does this mean?
Oh.
Whether an object's moving or sitting still, it wants to stay that way. Okay, we call this inertia. The first law describes inertia, the tendency of things to continue doing whatever they're doing. Right now, am I constantly pushing myself on these roller blades?
No. Yes.
Right now, am I pushing myself?
No.
Am I still moving?
Yeah.
Why is that?
Because they're wheels.
Because they're wheels, right? Why do the wheels keep rolling like right now?
Because they're not square.
After I stop pushing, why am I still rolling, Oscar? Inertia says that whatever something's doing, it would like to keep doing. My body has inertia right now, and that inertia wants to keep moving.
Oh.
There's no net force and I'm still, I'll stay still. There's no net force and I'm moving, I will keep moving. So inertia, after I push a couple times, inertia is now it's pushing me, right? My body's tendency to keep doing whatever it's doing. The law of inertia. What does my body want to do right now?
It wants to stay.
Yeah, wants to stay. What do you suppose would happen if the table moves underneath me? Okay, if I break my neck, you have permission to use your phones.
You get money.
Okay.
Shake, rattle, and roll. Yeah, you're not moving at all.
Okay. I didn't move. I might have moved a little bit, right? I didn't move much.
Go again.
Okay, we'll try it one more time. I'm gonna try to be brave and not hold on this time.
If you break your neck, you're gonna break.
Okay, I'm ready. What the inertia? So, my inertia.
What the inertia?
My inertia, my body's tendency, everything in the universe has a tendency to keep doing what it's doing. My body right now wants to stay still. So even though that table moved, my body's inertia keeps me in this line, right? Since there's not, since there's not a very much friction, my body wants to stay, the table moves. That's inertia. Okay, same thing. If I was moving, my body would want to continue to move. Okay, please look down and line up my table. There's this net force thing, right? It says if there's no net force, so this law says there's no net force, here's what happens. But what's a net force? I'm going to give you 5 minutes from when this QR code pops up to explore this simulation and try to figure out what a net force is. So, there are a few things you need to do. Hold on. See why I didn't put the QR code up right away? There are little guys. You see how there's little red guys and blue guys?
Yeah.
You're going to drag them onto either side of that cart, and they're going to play tug of war. Yes.
But there's a big guy on the right.
Okay, so you're going to experiment with, what if I put a big guy on one side, little guy on the other side, 5 guys on this side, 2 guys on this side, and you're going to try to figure out what is a net force. So the one thing that you need to do is, see up here where it says sum of forces?
Yeah.
Where my mouse is? You need to make sure that box is clicked when you play this. Okay? So I'm going to give you 5 minutes. What you need to do is screenshot a picture of net force, and you're going to add that to your opener for Newton's first law. I'll give you a hint. Once you click the sum of forces box, it's going to give you an arrow. Okay? A little arrow that says sum of forces, and that is going to tell you what your net force is. After 5 minutes, I'm going to ask you again, what's a net force? What does it do? Okay? Questions?
No.
Okay, here it is. Okay, so right now, on my screen, if I were to press go, what would happen?
Nothing.
Nothing, why?
Because there's nothing there. Nothing to pull it.
Hmm?
Because there's no force.
No force, alright. So, if I take this little guy, and this little guy, now I press go, what happens?
Nothing.
Why?
Because they're equal amount of force.
Equal amount of force, very good. So, if I now add this guy, why is it moving? Alex?
There's more force on the blue side than there is on the red side.
There's more force on the blue side than there is on the red side. The difference in those two forces, this little green arrow, this is a net force. Newton writes first law. It says, here's what happens. If there's no forces, there's no net forces, if all things are equal, here's what happens to our object, whatever it is. But, Newton says, okay, but what happens if there is a net force? What if one side is stronger than the other? He says an object will experience an acceleration. What does this mean? What does this law mean? So it says, in the presence of a net force, an object will experience an acceleration. Ashton, what do you think?
When something is like has force applied to it and
It'll move. Very good. Short, sweet, and simple. When there is a net force, when there's force applied to something, it'll change speed. Okay, now people mostly think of acceleration as going faster or slower, right? Like right now, I'm accelerating, going faster. It'll change speed. If I apply force to something, it'll change speed. Okay, but it says faster or slower, not just accelerate, right? So I'm going to push off and I'm going to accelerate. I'm going to go faster. Let me start from here. Okay, I'm going to apply force, I'm going to accelerate. So acceleration is not just faster, okay? Acceleration is a change in speed. Because right now when I'm slowing down, I'm still accelerating, but I'm accelerating towards zero. When I go faster, I'm accelerating in a positive direction. When I slow down, I'm accelerating back towards zero. Okay, so I'm just changing speed. So, if we apply force to something, its speed will change. Yeah, Carla?
is there like adding a negative to a positive?
Exactly, adding a negative to a positive, right? If I slow down, I'm adding negative speed. Think about it. It says not only will something accelerate, but depending on how big it is, it'll accelerate at a different rate.
Yeah,
Right
so?
here. Alright, so what I've got, you guys can see up on the screen, I've got two cars. This one has 10 washers.
And the other one has 20.
The other car has 40 washers. I'm going to apply the same amount of force to both of these cars. So, Newton's second law says if I apply force to something, what's it going to do? Huh? Accelerate, right? It's going to move, it's going to accelerate. So his law also says that the amount of acceleration has to do with how big the mass is. So, I'm going to pull both of these cars back to about here. We're going to apply the same amount of force. We're going to see which one goes farther.
They both do the same distance.
Someone's running on 3 wheels. That's interesting.
Yeah, it's held the end.
Nope, I've got a little line here.
Oh.
I'm going to let this one go. Okay, same amount of force, different amount of acceleration. Okay, Newton's third law of motion. For every action, there's an equal and opposite reaction. Everything pushes back. The bigger it is, the harder it pushes. So, if I push on this table, I'm going to go backwards because this table's pretty big. It's a lot heavier than me and I've got not much friction, right? So I push, I go backwards. I'm going to move probably. Okay, so we pushed against each other. I pushed that table that way, that table pushed me this way.
Get over here.
Right, so I'm not moving as fast as the... So this is how, like here's actual rocket science, ready? This is how we send stuff into space. Go. Okay, I'm going to blow up this balloon. When I let go of this balloon, what's it going to do?
It's gonna fly.
Okay, why? So this balloon is going to force air that way. And right here behind this balloon, is there some air?
No. Yeah.
Yeah.
It's like jet propulsion.
This is jet propulsion, right? This balloon is going to send air backwards. The air here is going to provide the opposite reaction. line here.
Oh.
I'm going to let this one go. Okay, same amount of force, different amount of acceleration. I'm going to provide the opposite reaction.
Ooh, that's totally wicked.